Brian. Great. Thanks everyone for joining today's webinar training. We have some exercise planned, so we can go ahead. It's great to see everyone's face. Brian and I think we saw all your data at some point, and it's good to put the face of the site, but also the data. Let's get started. So Brian and I will be in charge of walking through the material today. But we also have two team help prepare all the material here. Daniel and Yue, they might join at some point. So today's webinar is mostly for most of the people here is just prepare for the self-review process. We'll go through what the detail, what the self-review mean, but also what is the process involved just in the next 1 hour. But also, if you just want to sit in, just learn about what the QAQC is being done at the AmeriFlux, this is also a good venue. The schedule for today is we're going to have an intro about the self-review process to give you some idea about what's happened, what's behind the thing, and what happened, what to expect after you submit your data. And then we'll dive into detail to talk through all the QAQC module, the output, because those are the information you need in order to do self-review. We're going to have a breakout exercise. I'll be giving you some real cases so you can play a little bit to figure out and try the process a little bit and kind of mimic what's going to happen if you deal with your data. Then we'll close out by Q&A, maybe a little bit on what's next. The first two part of the work, this webinar will be recorded, just for your information. The recording slide will be available afterward. So let's get started. Brian, could you walk through this?
Sure, yeah. In the next couple slides, I'll try to give you a run through on how the self-review process is different than the regular data submission process y'all been on so far. Is there someone not on mute? Yeah, so starting with this overview slide, as you all been through this before, your data will first go through the format QAQC check and then data QAQC before getting published as a base product data set. And the AMP team will then combine your base data with your site information to generate the FluxNet data product for your site. Next slide, please. And on this next slide, we'll just hone into the base process. And after you submitted your data, you will receive a format QAQC report automatically within 10 to 20 minutes. And every 1 to 2 weeks, all the data sets that pass through format will be combined with previous base upload for that site and run through the 6 currently implemented data QAQC modules. So they are timestamp, physical range, diurnal seasonal pattern, multivariate comparison, variable coverage, and U-star filtering. Towson will dive into talk more specifically on each of these checks later on in the presentation. And each module, after being run, will generate its own summary statistics and figures to be compiled for AMP team to review. And these usually takes anywhere between 10 minutes to hours for us to review, especially for new sites that are uploading for the first time. So the typical workflow here is that, like you all have experienced, AMP team will send a summary report back to you, summarizing the issues found, or if it's all okay to publish. And since AMP does not do any filtering, all issues correction will require resubmission and go through the process again. Next slide, please. And now, in order to keep up with the growth of the network and the increasing number of submissions we've been getting, we implemented this alternative process called the self-review. And this will enable quicker submissions and assessments from the site team to address any data issues that was found. And this also free up AMP resources for adding new check modules and distribute effort to support new sites. And if you follow me into the flow diagram, now we dive into the self-review workflow. All steps leading up to data QAQC will be identical to the process you've experienced so far. And where the workflows start to differ is in the stamp report stage. So instead of AMP reviewing and providing a data quality report, you as a site team will review the summary statistics and figures generated in an email format. And then the site team can self-approve the data set by replying with your comment pass, or choose to resubmit the data on your own. And there's no need to let us know if you choose to resubmit. We'll just look out for your site's new submission and retire the data with overlapping timestamps. So next slide, please. To provide a little bit more context, the graph on the left shows kind of the total sites publishing and uploading data since 2013. And the plot on the right shows the total number of QAQC checks AMP performed throughout the years. And as you can see on both graphs, the network have grown pretty significantly since 2013. Particularly after 2017, we saw an increasing number of sites uploading data and implementation of the QAQC pipeline that we have in place currently allow AMP to keep up with this volume. And the self-review process was implemented in 2021, and 33 teams from 146 sites have participated thus far. And after 2022, roughly 50% of the data QAQC we received are through self-review. And if you look over at 2025, we're only in August of this year, but we received a surge of uploads that is equivalent to annual numbers from past years due to FluxNet 2025 data initiative. So this is one of the reasons why we're expanding this self-review cohort. And so thank you all for volunteering in this effort. Next slide. So now we'll talk more specifically on what to expect in each step of the self-review. Similar to automated QAQC format reports, after the data QAQC module executed on your site, you will automatically receive your site's data report in an email format. And in this email, you'll find in the title the date range of your base data, as well as when it was submitted. The email also outlined the steps of actions for the self-review workflow. So first step contains the link to the tech note, the technical document, where you can review if you need, and we'll show an example of this in the next slide. And step 2 contains the link to the summary statistic tables corresponding to each of the data QAQC modules. And we'll also show an example in this couple slides from now. Step 3 is if you spot any data issues that require correction, you can re-upload using the link. Or if no issue is found, follow option B and just let us know your data is ready for publish, and our team will prepare it to publish as base. Next slide, please. So this is one example. This is an example of the technical document. It outlines specific statistics used in each data QAQC check, and you can always refer to back to this tech doc to interpret your data QAQC results. And right now, you can also scan this code, put a link for the document, and we'll also put this into the chat later on if you want to use them during the case studies. Next slide, please. So this is an example if you download a summary statistics table. It shows QAQC results and statistics for each of the variable for your site and for each year and for all of the years. I find the link really helpful. I usually just copy and paste this on the browser, the figure links, the FTP links on the right. I usually just paste them onto a browser and I can visualize the data results for that one check. And for my own workflow, I actually like to download these and open it in Excel. And I would sort it by result column, and then I can just double check all the warning and fails corresponding to each data QAQC email. Yeah, that's it from me for the intro, and Howson will now talk more about consideration and statistics for each module.
Yeah, thank you, Brian. So I want to follow by this one. So in the next maybe 20 to 30 minutes, we'll go through each of the check. The structure will be very similar, right? So this is a figure tied to one variable or maybe two variable per period, so maybe a year. And also you have a summary statistic like this. And I'll go through what they mean and also give you some example of the figure, how they look like. Just some background about the QAQC. So I would say the QAQC we perform, I kind of interpret this as a secondary independent check, right? So most of you run your site, you must have some QAQC quality control at your site. And I believe a lot of those is you build over the year. Could be coming from the sensor, diagnostic signal, or could be ecosystem specific quality control measure. But our job is not to replace all those efforts. I think those still important, and those are critical one. Should be continued. What we're doing here is we kind of doing a secondary check when the data submit to us before we prepare them to share among the network, prepare them for FluxNet data. We do a check, make sure they kind of follow the standard like many other sites, and make sure they are ready to be one flux processing. So that's a lot of idea we're doing a check is slightly different compared to running a site like you. A lot of issue, or maybe the way we do the check is lesson learned from the previous FluxNet release, or maybe previous data use, feedback from the data user. So maybe slightly different from what you do QAQC on a regular basis. Another thing to note is we don't have a lot of information about your site. Sometimes we don't even know what sensor you're using or how you log your data. So a lot of things we perform, we have to rely on like a post hoc approach, right? With limited information, what can we do to check and identify potential issue? There are some trade-off between because as you know, we have more than 500 sites share the data available right now. So that means all this network, as all of you introduced in the beginning, coming from a very different ecosystem, very different climate. So sometimes we have to find a balance between the very specific check, or maybe try to do something very universal across the network. Last, because a lot of issue require some communication back and forth, so you can find that most of the check have one visualization available. It's easier for communicating. It's not necessary for the check. A couple module we have right now, Brian already mentioned, we do plan to add more in the future, but we have to make sure the workflow is doable and scalable before we adding more check right now. So the following slide, we have something like a structure like this. So a check module, I'll show you a couple of figure example. This is a very similar figure you will see when you do the self-review. But also they are the similar figure if you ever receive any QAQC email previously. The new thing would be the summary statistic table here, right? If you're doing QAQC previously, you probably won't see that because this is behind the thing. But now if you're doing a self-review, this will be the first thing you interact with. This is a CSV file. We show example previously. Then I will try to summarize what is a potential issue for each of the individual check, and also what variable is applied to this check. The first one is timestamp alignment check. This is to check whether your timestamp is correct. The way we did a check is we do potential incoming radiation calculate for your site based on your location, based on your time zone. And then this is one example. This is 15-day window for 1 year of data. Zoom in a little bit so it's easier to see. The blue line here, this is a potential incoming radiation calculated for this site. And we do a maxima diagonal composite. So each 15 window, we kind of try to capture the clear sky condition. This is a clear sky maxima potential incoming radiation over this 15-day. Then we compare them with your observed radiation. So the black line, gray line are your observed major radiation from your site. We use both shortwave and PPFD in this case. And for this case, everything looks good because yeah, your major radiation is kind of symmetric and also fall under the potential incoming radiation. Sunrise, sunset kind of align with what we expect. So everything looks good. This case give you example about the potential issue identified for this site. Again, zoom in, let's see this one, right? So the sunrise start earlier in this case, and the sunset also earlier this case. And all the point have larger than the potential incoming will be flagged, in this case, red one. And we also do the cross correlation between the two time series to determine the lag. So to give you an idea about, okay, the timestamp can be an issue in this case. A couple source of the the issue coming from, based on our experience, would be sometimes you just miss the timestamp is not what you expect, or maybe this is a time zone issue. You think you're using an Eastern time zone, but centrally it's maybe a central time zone. Or in some case, people using daylight saving, you see the shift also, or could be just a time synchronized issue for the clock, the logger, or maybe when you're merging the data together, it somehow misinterpret the timestamp. The corresponding summary statistics table will look something like this. This is abbreviated version. You'll see a longer version. You'll see which year, which variable we use for check. What is the overall result? Is that okay? What is the time lag between the potential incoming radiation and your measure radiation? If this is 0, it means, okay, everything aligned perfectly. What is the cross correlation coefficient here? These are the number of the point you have larger than potential incoming, right? So the first one will be everything's okay, you have nothing above potential incoming, the time lag is 0, so everything is okay. Second case we just see here, this one will return fail because it has a time lag at the one step. So this is half hour, and there are some point being flagged as larger than the potential incoming radiation. I want to mention we set a threshold here based on after some exercise. We don't want to flag everything and over flag everything potential warning, but also don't want to miss the potential issue. So the point here is kind of consider, okay, there are potential diffuse radiation happen at the sunrise, sunset, so we ignore those. And after ignoring those cases, how many point is likely trigger issue here. So this is how we set a threshold. I won't dive into a detail. We do have a full PDF documentation Brian mentioned. You can take your time to read it through, and this is how we set a threshold and how they trigger issue here. The second one is easier, more straightforward. This is kind of what is the physical limit for each of the variable. This check applied to pretty much all the variable coming into our place. You can use this to spot a potential instrumentation issue or just processing issue. Some case with just wrong unit or conversion issue, or maybe using a wrong missing value in your data set. And this is a figure how it look like, right? We define the yellow and the red line. This is what is the physical possible limit for this variable. Some variable we can define that, and some variable we can. So we relies on the community. So we seeing a lot of data. So we kind of build what is the distribution of each of the variable look like across the network, right? What is the long way incoming, long way outgoing? We define what is the upper bound, lower bound, and we use that as a way to say this is a possible limit. We do know a lot of variables, especially in measurement. You can have some buffer, like a borderline data, right? Let's say PPFD, the power measurement. It's very likely you have something very small negative value. So this is kind of the borderline. That's why we create a plus minus 5% buffer in this case. So the point outside will be flagged, right? Everything outside of the boundary plus minus 5% will be flagged as a hard flag point, and anything between these two will be the soft flag. And we're counting how many points each year they've been flagged as these two. So this is a summary statistic. This case will be this is par. There are some being flagged as a soft flag. We try not to overwhelming by the one at the borderline. So you see most of the case, unless you have a large certain number of the point outside of the buffer, then we'll flag that point. I want to mention, let's stop here for a second. So this is slightly different compared to how people do QAQC, right? Most of the time you do QAQC is you flag a point, you try to filter the data. But in our case, we didn't plan to filter any data. So the way we do QAQC is what is the percentage of the outlier is acceptable, right? So in this case, if that's less than 0.1% per year, that's roughly 20 to 30 point flag per year, or maybe less, then we just let it go, because a lot of time you just it's hard to have a outlier free data set in a sense, especially dealing with a lot of things. But also this is kind of the logic we're doing the QAQC control here. Of course, you can try to filter as much outlier as possible if you can, but this is roughly how we hold the standard here. This is a relative check. This is just to check in the unit of the whatever need to be in percentage. This is applied to soil water content, relative humidity, albedo, leaf wetness. All these variables should be in percentage 1 to 100%, right? But if you submit it in a ratio like a 0 to 1, this check will flag this variable. All right, moving on. As I mentioned earlier, physical range is more kind of more relaxed threshold, because think about across a network. If you're coming from an Arctic site or if a tropical site, the temperature range should be very different. The way we narrow it down is by adding this check. This is a diurnal seasonal pattern. This is 1 year of data. Each window is 1 month of data. The blue line, this is from historical data from your site, right? So think about here. This is a sensible heat from your site. This is 1 month window, and we do a diurnal pattern, and we try to derive what is a historical percentile for your data. This is a median. The lower might be 2.5% all the way to 97.5% of your data set, sensible heat. The gray dot is what you submit for this new data, and the black line is the median of your new data, right? And everyone here is most of the variable we're dealing with, they have very strong diurnal pattern, very strong seasonal pattern. So you can narrow it down, like 10 o'clock at this month, what is the possible range of your sensible heat look like? And we did compare with the previous data. So this here give you a much more constrained control of what the variable should look like at your site. But because this requires historical data, so this can only apply to returning site, right? You have previous base being published already, ideally more than 3 years, so we can build this for your site. So when you submit your new data, we can do a comparison. Okay, and this case will be, this is a soil heat flux in this case. You can see the new data has a very different diurnal pattern at this site. The overall range is not so different, so it might miss in the physical range. But in this case, it can be captured by the diurnal season. And in this case, this site has a flip sign convention, so everything's kind of flipped. I don't know if it's a sensor issue or it's a processing issue, but this gives you some idea. Okay, your data now is, a lot of data is outside of your previous historical range. This is another case how we use this check. This is a long way outgoing. This site has more than 10 years of data. And if you look closely, all the new data seems to have a larger long way outgoing in this year compared to previous record, right? If you look back to the time series, this is a time series over multiple years. This year, again, confirmed this year has a much higher long way outgoing. A little bit warning about this check. I do got an email about this check a lot. CO2 temperature, potentially you could have a false warning, especially for CO2. If you're running a long-term site, and very likely your CO2 already exceed whatever your long-term record would be. So just be aware as a potential false warning. And this is a table look like, again, which year, which variable, what is the overall result. Mostly we rely on the percentage of the data set in the interquartile range, but also outside of the 95% range. We have a threshold about at which level they will trigger a warning. We also do similar cross correlation, but we don't use that very like a very restrict, like a time series. Sorry, like a timestamp check. This is because not every variable have a very strong diagonal pattern. So sometimes you can trigger a false warning just looking at this one. Think about soil temperature or maybe soil heat flux, right? So the time alignment is not that perfect compared to incoming radiation. So just be aware. So moving on to so far we're using mostly just one variable to do checking. The next one will be the multivariate checking. In this case, we're using the show incoming compared to PPFD, the time series for both variable here. And we plot them. This is 1 year of data. Then we plot them against each other. By nature, there will be some point a little bit outside of the relationship, right? So we call potential outlier. That doesn't mean they are wrong. It just the way we do check is we flag the point a little bit relative outside of the regression line. But it's not an issue here. In this case, there are some issue in this case. You can see there are more points being flagged outside of the regression, right? And if you look at the time series of this flag point, they also happen across a season, a certain time of the day. So in this case, this is one of the radiation got shaded. So every certain point of time, certain point time of the day, one of them will be lower than the other. Another thing looking at the multivariate check will be looking at the long-term trend, right? So this is a 10 years time series for PVFD and show incoming. And this is a regression slope and how they change over the year. And in this case, the change could be, this is almost 20% if you think about the regression slope over the year, right? And if you look at the time series, right, so one of the sensors kind of, this one degraded over time and you change another one and you maybe change another sensor. So it's kind of the slope change over time, and this is how you get flagged. So this is a table look like. Again, I'm just trying to give you some idea, and you'll see this table more often when you submit your data, and you can take your time. Time period, variable one, variable two, and what is the result? A couple of things we're looking at will be the regression slope, what is the R square, what is the deviation of the slope compared to a long-term mean of the slope, and what is a potential outlier being flagged in this case, right? So a small percentage of the point being flagged is okay, but if you reach certain threshold, it'll give you a warning and have you to take a look. This one is straightforward. This is just for U-star filtering, and everyone here should know we ask you not to U-star filter your flux data, and this is because in the next step we're going to do the U-star filtering. So the check here is very straightforward. I don't think you'll see this because everyone here should know already. This is just to tell whether your CO2 flux is being filtered by U-star or not. In this case, if it's filtered, the lower bound of the U-star will be very different when you have when the CO2 flux is not missing or when the CO2 flux is missing. So this is a logic, but I don't expect everyone here will be needed to check this one because yeah, you probably know this already. Again, this is a table associated with this check. This is just to try to understand what is the lower bound of the U star for different case they would expect. The last check we did, this one doesn't have a CSV file or the table. This one only has the figure. This is a variable coverage. A couple thing is take a look of this one and you can use this one to identify a couple things. Are there any long gap? This shouldn't be appearing. Or are there any variable just missing for a certain period of time that shouldn't be? Or are you using the same variable qualifier over the year? In this case, everything's FC111 over the year. This is kind of to check, make sure everything is back. Because a lot of people, they only submit the last year of data, not the entire record, so you might forget what you used for a variable name last time. So I'll stop here for a second. Any quick question for any of the check before we move on to exercise? Feel free to raise your hand or and unmute yourself if you have any question.
I have a question, Hudson.
Yes, Jeff, go ahead.
Maybe I missed this. Is it possible so if you go through the check and your submission has these hard flagged points, is it possible to click a button and say, yes, delete, screen those out and just then publish the screened data?
A couple of things here. So first, we don't screen data. So we don't do any filtering. So whatever you provided, if it passed, it'll be published and people can download it. So there are a couple of things to think about here, right? So ideally, we want to filter the data as clean as possible. But what happens if there are 2-point outlier out there? Are you willing to resubmit a version? Are you okay to let it go? And so people can take care of themselves. So there are a couple of things here. So that's why we try to set what is acceptable percentage of outlier, and the data user might be able to take care of it. That's the first thing. Second one is right now we don't have a button for you to click and to go ahead. The way I think Brian mentioned earlier would be just reply email, right? Say yes, go ahead, or maybe just show description about okay, there may be a few fail warning, but that looks good to me, and usually we just let it go. Yep.
Okay.
Any other question before we break out, do some exercise? Okay, let's go see some real cases.